Hello everyone, welcome to the new video lecture of subject Interconnected Power System. Myself Himanshu Joshi, I am an assistant professor in Sri Labhubhai Trivedi Institute of Engineering and Technology, Rajkot. So let's continue our next topic based on the chapter number 6, that is the power system stability. So let's basically define a word, name is infinite bus. Clear? So infinite bus is the connection of group of machine on such system in which we have connected the group of machine. In that system, it would not affect the magnitude and phase of voltage and frequency. So infinite bus is nothing but the group of machine, and in that particular system, if the magnitude of voltage and frequency is constant, then that type of bus is known as infinite bus. So we can say that on such system of constant voltage and constant frequency, regardless of load, is called infinite bus bar system, or simply known as infinite bus. Clear? So we can say that in infinite bus, the effect of change in load is negligible. Clear? So we can say that on infinite bus, voltage is constant, frequency is constant, and the change in load is almost negligible. Clear? So we can say that infinite bus is the constant voltage and constant frequency bus, and infinite bus is also known as ideal voltage source. Clear? Infinite bus is also called as ideal voltage source because in infinite bus there is no effect of excitation and governor action, because we know that excitation is change or governing action is comes in picture when there is a change in load. But in case of infinite bus, there is no effect of load. Clear? So infinite bus is almost constant voltage and constant frequency bus. So in short, a bus on which voltage and frequency are constant, that particular bus is known as infinite bus. So let's discuss the single machine which is connected to infinite bus. So as shown in figure, a single machine connected to infinite bus through a line, through a transmission line which is having a reactance of xt, and this machine will supply the power to infinite bus. So we know that power transfer on transmission line is given by EV by X total sin delta. So EV by X is basically P max, and X total in this case is XD plus XT, because both are in series. So X total is equal to XD plus XT, and swing equation is given by H upon pi F d square delta by dt square is equal to Pm minus Pe. So this is the power angle equation and swing equation for single machine connected to infinite bus. Now let's consider the two machine system. We are trying to derive the power angle equation and swing equation for two machine system. So two machine system is shown in figure. Machine 1 is considered as generator, machine 2 is considered as motor. Clear? Total reactance of entire system is XD1 plus XT plus XD2. So one machine act as a generator and another one is act as a motor. So one machine is generator, another is motor. Now mechanical power input to generator is PM1 and its electrical output is PE1. Clear? PM1, that is the mechanical input for generator, PE1, that is the electrical output of generator. Now on the same way, PE2, that is the electrical input to the motor, PM2, that is the mechanical output of motor. So we know that accelerating power is given by PM minus PE. So this is the first case. Now please make a note that we have considered over here a lossless system. We have considered the lossless system. So each and every power are equal to each other. That means mechanical power is equal to mechanical power input is equal to mechanical power output for generator and motor. Clear? This is the mechanical power input to generator is equal to mechanical power output of motor. Now in the same way, electrical power output of generator is equal to electrical power input to motor. So magnitude of each power are equal to each other, but the direction is opposite of each other because first one is input, another one is output. So over here I have written that PM1 is equal to minus PM2 is equal to PM. Clear? And PE1 is equal to minus PE2 is equal to PE. So based on this three equation, we are trying to derive the swing equation for two machine system. So let write for machine 1. Clear? So for machine 1 I can write m1 d square delta 1 by dt square is equal to PM1 minus PE1. So I will put m1 is equal to h1 upon pi f d square delta 1 by dt square is equal to PM1 minus PE1. Again I will keep d square delta 1 by dt square and on the left hand side. The remaining I have to shift on right hand side. So d square delta 1 by dt square is equal to this pi f will be multiplied with PM1 minus PE1 and this h1 comes on the denominator of PM1 minus PE1. So d square delta 1 by dt square is equal to pi f multiplied by PM minus PE upon h1. Now consider PM1. So from this equation I can write PM1 is equal to PM and PE1 is equal to P. So the equation for machine 1 is look like this: d square delta 1 by dt square is equal to pi f multiplied by PM minus PE upon h1. We have replaced PM1 and PE1 from this. PM1 is equal to PM, PE1 is equal to PE. So this is the equation 1 for machine 1. Now on the same way we have to write for machine 2. So m2 d square delta 2 by dt square is equal to PM2 minus PE2. Consider machine 2 is motor. Machine 2 is motor. So I will replace m2 by h2 upon pi f d square delta 2 by dt square is equal to PM2 minus PE2. Again I will keep d square delta 2 by dt square on left hand side, another on I have to shift on right hand side. So pi f multiply with PM2 minus PE2 and h2 will comes in the denominator. So d square delta 2 by dt square is equal to pi f multiplied by PM2 minus PE2 upon h2. Now PM2 over here you can see that minus PM2 is equal to PM. So I can write plus PM2 is equal to minus PM. Clear? If I will write plus PM2, so this minus will be comes over here. So PM2 is equal to minus PM. Again PE2. So this minus PE2 is equal to plus PE. So this minus PE2 is equal to plus PE. So PM2 is equal to minus PM and minus PE2 is equal to plus PE. So our equation, final equation for machine 2 is d square delta 2 by dt square is equal to pi f. I can write P minus PM instead of minus PM plus PE. So d square delta 2 by dt square is equal to pi f PE minus PM upon H2. So this is our equation number 2 for machine 2. So subtract, let's do the subtraction of equation 1 from equation 2. So this is our equation 1, this is our equation 1, this is our equation 2. So let's subtract equation 1 from equation number 2 or 1 minus 2. So d square delta 1 by dt square minus d square delta 2 by dt square, clear, left hand side, subtraction of these two, second order differentiation, d square delta 1 by dt square minus d square delta 2 by dt square is equal to this first part, pi f into Pm minus Pe by H1, pi f into Pm minus Pe by H1 minus pi f Pe minus Pm upon H2. So let's simplify this. So this will remain same, this part is also same as above. Now again I will take minus common from Pe minus Pm. So I will take minus common, so Pe minus Pm become Pm minus P, and this minus multiply with this minus, so it will become plus, clear. So simplification will look like this, minus will be common from here, so this term become Pm minus P and this minus become plus. So again let take d square by dt square as a common, so d square by dt square, so in bracket remaining term will be delta 1 minus delta 2, and again in this equation we have taken pi f Pm minus P is common from both this term, pi f and Pm minus P will be common from these two term. So this is the pi f and this is the Pm minus P. So remaining term from this two term is 1 upon H1 plus 1 upon H2, clear. So this is the equation that we have write in our last slide. So d square by dt square delta 1 minus delta 2 pi f Pm minus P as it is. I will take H1 into H2 as our LCM. So denominator is having a H1 into H2 and numerator we are having a H1 plus H2. So let's convert this equation into our standard equation. So standard equation is H upon pi f d square delta by dt square is equal to Pm minus P. So in right hand side we need only Pm minus P. So I have written Pm minus P. So I have to shift pi f and this term on left hand side. So this pi f is in numerator, so it will comes to the denominator, and this part also comes to the denominator, but I have written in form of numerator. So H1 comes to the numerator, H1 plus H2 comes to the denominator. So this is the equivalent H, this is the equivalent delta of our standard swing equation. So I will take H1 into H2 upon H1 plus H2 as our H equivalent, and delta 1 minus delta 2 I will consider as single delta. So equation become H equivalent upon pi f d square delta by dt square is equal to Pm minus P. So H equivalent is equal to H1 into H2 upon H1 plus H2, and delta 1 minus delta 2 is equal to delta. So this is the standard equivalent swing equation for two machine system, clear. For two machine system, equivalent inertia constant is equal to H1 into H2 upon H1 plus H2, and equivalent angle delta is equal to delta 1 minus delta 2. And next, electrical power, or we can say that power angle equation for two machine system is E1 into E2 divided by X total. Clear? So over here, X total is XD1 plus XT plus XD2. So electrical power interchange is given by PE is equal to E1 into E2 divided by X total, which is nothing but equal to XD1 plus XD2 plus XT into sin delta. So I can write E1 into E2 divided by X total. This is the X total into sin delta. So this is the power interchange equation or power angle equation for two machine system. Now let's talk about the one of the most important topic, that is the steady state stability. So we already know that the definition of steady state stability. So steady state stability limit of particular circuit of power system is defined as the maximum power that can be transmitted to the receiving end without loss of synchronism. It's known as steady state stability limit. So now steady state stability is the ability to regain the normal and stable operation after being subjected to gradual or slow change in the load. Clear? Gradual or slow, or we can say that small and slow disturbances. So ability to remain in normal and stable operation after being subjected to small and slow disturbances. It is known as the steady state stability. So consider over a single machine. Clear? Consider the single machine which is connected to infinite bus. Single machine connected to infinite bus. Clear? So for that particular machine which is connected to infinite bus, the swing equation is given by m d square delta by dt square is equal to Pm minus Pe, and m is the angular momentum of machine and it is given by h upon pi f, and that machine will transfer the electrical power over the infinite bus is given by Pe is equal to Ev by Xd into sin delta, and we know that Ev by Xd is equal to P max. So Pe is equal to P max into sin delta, and this is the power angle equation, and this is the power angle curve which you can show over here in your screen. So swing equation and the power angle curve for that particular swing equation is shown over here. So we can say that let the system is operated for steady state stability limit, and power transfer, and that initial power transfer is given by Pe0. Clear? So initial load angle is delta 0 and initial power transfer for that particular infinite bus is equal to Pe0, and that Pe0 is equal to mechanical input. Clear? Because we have considered the lossless system, so that initial power over infinite bus is equal to Pm, mechanical input, and its equivalent electrical output is P0, and for that particular power the power angle or load angle is delta 0, which you can see in this particular figure. Now consider this small increment in power. Consider this small increment in power. Clear? Consider the small increment of power. Let's suppose that power is delta P, delta Pe. Consider that increment in power is delta P. So initially power is P0. After the increment, power become P0 plus delta Pe. So this delta Pe is the increment in power. So that increment in power will causes the change in load angle by delta delta. Clear? Due to that increment in power, angle will change from delta 0 to delta 0 plus delta delta. Initial angle is delta 0, new angle is delta 0 plus delta delta. This delta delta is the change in angle due to change in electrical power. Clear? So the initial operating point for load or machine on this curve is P0 delta 0. Initial operating point is PE0 delta 0. Now with change in electrical power or change in demand or change in load will cause this stable point will shift from P0 delta 0 to P0 plus delta P to delta 0 plus delta delta. Clear? So this is the work of power angle curve. Now, so this is the initial power and initial angle. If change in power from P0 to P0 plus delta P, and due to that angle will change from delta 0 to delta 0 plus delta delta. So let make this curve as a linear one. Clear? So that we can get this easiest mathematical equation. So let linearizing the point, linearizing this point P0 delta 0. So I can write that change in power will occur change in angle delta, and that change in angle delta or change in power is proportional to the del P by del P by del delta. Clear? This is our point which we want to make linearize. So this is the increment in power, and due to that increment in power, this delta will change in angle, and this change in angle is proportional to the change in power with respect to change in delta. Clear? This change in delta is due to change in power with respect to change in angle delta. So for that I can write delta PE is equal to del PE by del delta multiplied by delta delta. Now consider the equation, swing equation, m d square delta by dt square is equal to Pm minus P. So I will write m d square delta by dt square is equal to Pm. I will replace P by P0 plus delta P. Clear? P will change from P0 to P0 plus delta P. So PE is equal to P0 plus delta P. Now initially P0 is equal to Pm. Over here I have told you that initial we have considered the lossless machine. So initial operating for electrical power and mechanical power both are same. So we will put P0 is equal to Pm. So this both will get cancelled out. So equation become m d square delta delta by dt square is equal to minus delta P. Now we can write delta P is equal to this del P by del delta 0 multiplied by delta delta, because we have written over here delta PE is equal to del P by del delta initial point, so 0 delta delta. So over here we can replace delta PE is equal to del P by del delta 0 delta delta. So this is the minus term, so we will write on left hand side of equal to, so this minus become plus and entire equation equal to 0. So m d square delta delta by dt square plus del PE by del delta 0 delta delta is equal to 0. So this is our final equation. Now instead of d square by dt square, instead of d square by dt square, I will simply write p square. So equation become mp square delta delta plus del p by del delta 0, delta delta is equal to 0. Now in both equation delta delta is common, so I will take delta delta outside of the equation. So equation become mp square plus del pe by del delta 0 multiply by delta delta is equal to 0. Now this angle, change in angle is non-zero, clear. So delta delta is not equal to 0, it's non-zero term, so it will come in the denominator of 0, so it will become 0. So equation become mp square plus del pe by del delta 0 is equal to 0. We will shift delta 0 in the denominator of 0, so it will become 0. So this is our equation, this is our equation. So so this is the second order equation. So it's having a two roots, it having a two root. So first of all let's find out p square. So p square is equal to minus of del p by del delta 0 upon m, and let's take the root of this equation. So p12, two roots, is equal to plus or minus the entire equation in square root. So p12 is equal to plus or minus in bracket minus del p by del delta 0 upon m raised to 1 half. So this is the roots of equation. So now this roots of equation is possible that greater than 0, possible that less than 0, or it's also possible that is equal to 0. But this all three possibility will depends on del pe by del delta 0, because angular momentum is constant. So the nature of these roots is totally depends on change in electrical power with respect to change in angle delta. So suppose that change in power with respect to delta, that means del pe by del delta 0 is greater than 0, clear. So this root is greater than 0, so I can say that this entire term is become negative, clear, is become negative, because this change is positive, m is also positive, so this ratio become negative. So roots of this negative, square root of this negative is purely imaginary, and both roots are complex conjugate because it is a plus or minus, it's a plus or minus. So we have learned from our subject of control system engineering is that if roots are imaginary and complex conjugate of each other, then system is stable, clear, system is stable. Let me again explain another time. Suppose del p by del delta 0 is greater than 0, so this term is greater than 0, so the term in bracket is negative. So the roots of any negative term is purely imaginary, clear, is purely imaginary, and it's having a plus or minus sign. So we can say that roots are purely imaginary and conjugate of each other. And from our subject control system engineering, we have learned that if roots are purely imaginary and conjugate of each other, then system is stable, system is stable. So if del p by del delta 0 is greater than 0, then our system is stable. Now suppose let's take the another condition, del p by del delta less than 0. So if this term is less than 0, so this is negative and this is the minus sign, so minus minus become plus. So we can say that roots are real. So square root is having a two part, positive and another is negative, clear. So one root is positive, one root is negative, but we also learned that to make the system stable, all the roots of equation must be on the left half of 4 quadrant. Clear? But what will happen over here? One root is positive, that means in right hand side, another roots in left hand side. But to make this table, all roots should be on left half of this 4 quadrant. But over here, one root is positive, that means in right hand side. So system is unstable. System is unstable. Clear? If roots are imaginary and conjugate, system is stable. If roots are real, but one root is in right hand side, so system is unstable. So if del P by del delta is less than 0, the system is unstable. Now if it is equal to 0, if del P by del delta is equal to 0, then we can say that system is neither stable nor unstable. System is at its stability limit. System is at stability limit. So these are the three conditions. If del P by del delta is greater than 0, system is stable. Del P by del delta is less than 0, system is unstable. And if del P by del delta is equal to 0, then system is at limit. That means it is on the state of that it can be stable or it might be unstable. Clear? Depends on the change in del P by del delta. So we have given a special name for this particular term, del P by del delta 0. It is known as synchronizing power coefficient. Synchronizing power coefficient, or it's also have the second name of stiffness of synchronous machine. Del P by del delta 0 is also known as stiffness of synchronous machine. So let's define the synchronizing power coefficient. Let's define the synchronizing power coefficient. So it is known as the ratio of change in electrical power. Change in electrical power del PE to change in torque. Change in torque angle. That means this ratio del PE by del delta is known as synchronizing power coefficient. So ratio of change in electrical power to the change in load angle or torque angle delta is known as synchronizing power coefficient, del PE by del delta. So we are having a equation of P, EV by X into sine delta. So from this equation, if we differentiate this equation with respect to delta, then we will get the synchronizing power coefficient, del PE by del delta. So del PE by del delta is equal to EV by X. Differentiation of sine delta is equal to cos delta. Clear? So synchronizing power coefficient is given by EV by X into cos delta. So now to make the system unstable, or system is unstable if this ratio is less than 0. This ratio is less than 0. So I can write EV by X into cos delta is less than 0. Now EV by X all are the non-zero term. So if it will goes to the denominator of 0, so it will become 0. So from this I can write cos delta is less than 0. Cos delta is less than 0. So cos delta is having a negative value when delta is greater than 90. Clear? Cosine function becomes negative for delta or angle become greater than 90. So if cos delta is less than 0, then delta must be greater than 90 degree. So to make this system unstable, the limit is look like this. If delta is greater than 0, then system become unstable. So you can say that if delta is less than 0, system is stable. Delta greater than 90, system is unstable. System is unstable. But if delta is less than 90, system is stable. So we can say that if delta is equal to 90, then it's called stability limit. Delta is equal to 90 is called stability limit, because if delta change from 90 to upper level, it will become unstable, and if it will reduce from 90 degree, then it will become stable. So equal to 90 is known as stability limit. So the maximum power that can be transferred without loss of stability or synchronism is known as stability limit, and for that stability limit is for delta equal to 90. So we can say that PE is equal to EV by X into sin delta. So sin 90 you will get the maximum power without loss of stability or synchronism, and it is known as stability limit. So stability limit will occur at delta is equal to 90. So that maximum power is equal to EV by X. Maximum power is equal to EV by X. So this is all about the steady state stability. So over here we have learned that when system becomes stable, when system become unstable, when we will get the stability limit. We have learned the synchronizing power coefficient, and we have also derived the angle limit to make the system unstable, stable, or to achieve the stability limit. So that is equal to delta is equal to 90 degree. So thank you very much. With this we have concluded our session. If you have any doubt, any question, you can give your doubt and question in comment section. And if you like my video, then please like it, share it, and subscribe my YouTube channel to get the videos like this. Thank you very much.